Problem 5. The integral of 2x squared plus 9 over x cubed plus 9x. We can factor the bottom of that fraction into just x and x squared plus 9, and that's as far as we can go because we can't factor x squared plus 9. So the temptation is to just do what we've done in other problems and say, well, we have an integral of a over x dx plus integral of b over x squared plus 9 dx. But there's a problem with this. And the problem is related to what are called proper fractions. It is okay for me to write 5 over x, that's proper. Negative 3 over x, that's okay. And you can have 2 over x squared plus 9, 3 over x squared plus 9. But we can make that numerator bigger now. 5x plus 2 over x squared plus 9 is proper. Likewise, x minus 4 over x squared plus 9 is proper. So what happens in this what we call a quadratic case, the x squared plus 9 being unbreakable, is you have to build a more complex numerator. So we're going to break this down into a over x just like we've always done. But then when we get to the integral of x squared plus 9 in the denominator, we're going to put a bx plus c because that would make it still proper. And we do what we've done before, multiplying by the common denominator, which is x times x squared plus 9. On the left, of course, the denominator disappears, and we just get the numerator, 2x squared plus 9. On the right, when we distribute that x times x squared plus 9, we are left with a times its missing factor of x squared plus 9 plus bx plus c times its missing factor of x. And the question becomes, should we use convenient values? Now, the only convenient value I see is x is equal to 0, and we have 3 unknowns. So I would, again, switch to a different process here. So we're going to equate the coefficients. So we have 2x squared plus 9 is equal to a paren x squared plus 9 plus the quantity of bx plus c being multiplied by x. So we distribute in both cases to get 2x squared plus 9 equals ax squared plus 9a plus bx squared plus cx. Moving things around a little bit, we'll put the x squared terms together and get 2x squared plus 9 is equal to ax squared plus bx squared plus cx plus 9a. Now we can factor that ax squared plus bx squared into a plus b times x squared. Cx and 9a staying the same. And now we're ready to equate the coefficients. So we can see on the left, 2x squared is the only x squared term. On the right, a plus bx squared. So that must mean that 2 is equal to a plus b. Now there's no x's on the left. We have a cx on the right. So that means c has to be 0. And last, 9 is equal to 9a, which means that a better be 1. If we back over to that a plus b is equal to 2, we then figure out that b is 1. So now we know that a is 1, b is 1, and c is 0. And now we can take our integral of 2x squared plus 9 over x cubed plus 9x, separate it into two smaller integrals, integral of a over x plus the integral of bx plus c over x squared plus 9, but we know that a is 1, b is 1, and c is 0. So we get the integral of 1 over x dx plus the integral of x, no c there, over x squared plus 9. The second integral needs a u substitution, where u is equal to x squared plus 9, du is equal to 2x dx. First integral, simple, natural log of the absolute value of x. Balancing by putting a 2 on the inside, half on the outside, we get half of the integral of 2x over x squared plus 9. We get a half then of 1 over u du, which is equal to 1/2 natural log of the absolute value of u. And we end up with a final answer of the natural log of the absolute value of x plus 1/2 natural log of the absolute value of x squared plus 9 plus c.